Hi everybody. My name is Fionn Atkins, and I'm a postdoctoral research fellow at the University of Cape Town in South Africa. I'm delighted to be here. Thank you so much for inviting me to speak today. I'll be keeping it very simple and as short as possible, but I'll be talking about urban metabolism for coastal and urban resilience. Okay, so what is urban metabolism? In case you don't know, it's it's a relatively new field, emerging field that essentially helps us understand and quantify the flows of resources into a city, within a city, and out of a city. And it's a tool that is key to understanding our human nature interaction and how we can ultimately improve that relationship. So, to my mind, the ultimate achievement of urban metabolism is to move away from what we are currently in, which is this linear metabolism, linear economy, towards a more circular economy or circular metabolism where we essentially internalize our externalities. We reduce our inputs and we reduce our wasteful outputs. And these resources can be anything. They can be water, energy, plastic, etc. But I look at it from a biogeochemical perspective. So if we look at it in terms of carbon or nitrogen, which is my field, we can start looking at, and urban metabolism can help in linking these biogeochemical cycles to the more human aspects of the system, such as human choice, urban planning, urban design, and policy. So just to give an example of a nitrogen budget, this was done for the city of Paris about 10 years ago. It gives us a very good idea of the magnitude of the fluxes across the urban landscape. So just to kind of explain this green line here is the urban boundary, your urban system. And what flows into the system are imports, and what flows out is exports. Okay. So in this case, for the case of Paris, and is often the case in many cities, a large import of nitrogen is in food. So that's consumed, it enters into wastewater streams, and then is treated. So either is lost back into the atmosphere as in the form of, or by denitrification, the process of denitrification, or it's taken out of the system via sewage sludge, or it is discharged into receiving waters via or as treated effluent. So this is, for the purposes of today and this community, this is where I focus on and where I highlight where remote sensing can contribute to filling in the larger picture. Remote sensing obviously can contribute to other aspects of this holistic systemic budget, but I focus on water quality. So to put urbanization into, if I may be so bold, into an African context, globally we are becoming a more urban society. By 2050, we'll have about 70% of people living in urban areas. In sub-Saharan Africa, slightly less, but the rate of change is much more dramatic. So Africa is one of the fastest, or if not the fastest, urbanizing continent. And the provision of water services, such as supply and sanitation, is not keeping up with this urban population growth. So here we have water supply and sanitation comparing urban and rural areas. So if you look at the Atlantic region or the Atlantic coast of Africa, a large proportion of that coastline has less than 50% of water supply, and even less so in sanitation. If you look at rural areas, much less so. I was actually very interested to hear about Victoria's urbanization indicator. It would be very interesting to see how that applies in this context, simply because the lines between rural and urban are slightly blurred in many African countries. It would be very interesting to see that. But so this lack of this poor sanitation service supply is problematic for receiving ecosystems. So that's rivers and the coastal zone, and the services they provide to the city or to the populace of that area. And generally, there's quite good agreement that there's a data deficit in many countries on the continent, especially at the metropolitan municipal scale. So with the understanding that we can't manage what we don't measure, there is a real need to come up with other ways that bypass institutional problems. So I look at Cape Town. I'm looking at Cape Town as a case study. I'm looking at a watershed nitrogen budget for the city of Cape Town, but I focus on just a watershed or a catchment scale for now, which is within this box here. For the city of Cape Town, it's plenty of coastline. This black line here indicates the system boundary, our metropolitan boundary, but you can go to a slightly more larger regional scale. So we have, in terms of water services, we have aging infrastructure, frequent raw sewage discharge into the ocean. This is an image of a raw sewage discharge into the Atlantic Ocean, coming from one of the most affluent areas of the city of Cape Town. We've also got poor sanitation provision in a large area of the city, a lot of informal residential areas. And we also have periodic flooding where stormwater canals are inundated with all sorts of other pollution as well. And this discharges into urban rivers that eventually land into the sea, which is this one here. So this is Cape Town. This is a relatively well-resourced metropolitan area. And by comparison to many cities on the continent, we have a fairly robust data collection. The city provides a lot of information if you ask for it. But still, there are many instances of poor data transparency, if it exists at all. For example, our wastewater treatment systems often cannot comply to the national standard. So ultimately, our total nitrogen output into the marine environment for the city of Cape Town is largely unknown. So I'm looking at how we can start to fill in these gaps. One of the ways is to begin to quantify the inputs of nitrogen into the system. So I do this by linking land use or land cover to nitrogen loading. Here, this is our watershed, and we've got different land cover types, such as shrubland grassland, our fynbos area. In pink here, this is informal residential. In yellow, this is formal residential. We also have peri-urban agriculture, which is a large source of nitrogen into the system. We've also got wetlands, and this is our wastewater treatment works that discharges straight into False Bay, into the ocean. So the main role of this, or the main aim of this, is to identify missing data gaps in the nitrogen budget. So looking at land use and assigning a certain loading rate based on literature is one aspect. And then the other aspect is, in the absence of municipal data collection, remote sensing to fill in the gaps. So in this case, we have a fairly good data time series, but there are many watersheds in the area that do not. So this is the primary focus of this research so far. In the interest of time, I think I'm going to stop there, and I try to keep it as simple as possible. So please do ask me questions if you have any. Thanks very much.